Howdy.
Hi.
Okay. Do you guys see stuttering? By that I mean the our pictures and everything just sort of jump, jump, jump rather than move smoothly.
They look okay to me.
Is it moving smoothly to you?
Yeah.
That's probably my stupid cheap camera, and that doesn't affect you, so I don't mind. I bought it. I think I told you. I went to Office Depot when it was in business, and they said they didn't have any webcams. Uh, so I ended up getting it off of Amazon. Took my chances, but I don't remember this stuttering bit. So you're not seeing it, so I'm happy. Any questions? Okay, we got a test next Thursday. Lecture test one. What we go over today will not be on it. What we go over next Tuesday will not be on it. It's through last Tuesday, the lecture on myofibrils. I'll take part of Tuesday and review that little piece at the end of our last session on myofibrils for you. It'd be nice if you had some questions. On the other hand, having no questions may mean you know it all. So, uh, but if you don't, then you should have some questions. You know, it's a 100 question test, multiple choice, and almost all text based. There's a few uh, questions using those myofibril images, but not many. So I'm guessing that mostly what you'll be studying this weekend, with what time you devote to this class, will be the lecture material. And it's all the lecture material from the start, and it's all the items that are identified as lecture. Okay. So you want to go through that. You want to go through it so many times that it becomes boring. Unfortunately, you seem to yourself to have it memorized, like you went through it 5 times, and now I'm not getting anything further out of it. You probably finished studying then at that point, and you'd be really well set to take the exam. Over the weekend, if you've got questions, of course, email me. I'll get to them probably right away. Not planning on going anywhere. Okay. I've got the first 3 weeks of modules condensed, out of the way, so that when I jump back and forth between a picture to show you, and then we want to come back to the contents page here, it doesn't jump up to the top and I have to scroll back down again. So if you come across this, if I happen to leave it that way, you just open it up with the arrow, and everything's there. I don't think we're going to need any of that material today. Okay. And we will need that. We're starting on 923 today, digestive system. Okay. So I finally got off of things like meiosis and mitosis, which you're going to be studying, unfortunately, this weekend. Okay. But into real anatomy. Okay, digestive system. A lot of this is common sense. A lot of anatomy is common sense. We've lived with ourselves all our lives. The functions of the digestive system. I've listed 6 for you. There are a few others, but they're not as important to us. The first function is mechanical digestion. Mechanical digestion would be like biting into an apple and breaking it into a smaller piece. Okay. Mechanical digestion would be taking a hard candy or a candy cane or something like that, and just chewing it, breaking it, but you're not digesting it except mechanically. Mechanical breakdown is breakdown of food to smaller size. No chemical change. That's not the ultimate intention, but with one food, it turns out to be the case. Celery. Okay. You can break down celery mechanically, but you can't digest it. You cannot digest celery. Okay. Any question about mechanical digestion? It's pretty straightforward. Then we have the important one, or more important, chemical digestion. That's the breakdown of food with a chemical change. Starch will be converted to sugar. Proteins will be broken down and converted to amino acids for the body to absorb and to use. What major food group or type did I leave out? I said starch, I said protein, but I left out what?
Fats.
Fat or lipid, okay? And that's because it's not digestible. It's not digestible chemically. It could be digestible mechanically. If somebody wanted to take a piece of lard and chew off a piece, I can't imagine that. But fats do not break down chemically. They are emulsified. We'll get to that in just a second. Back to the chemical digestion. Okay. That's where you change starch to sugar. And changing starch to sugar. I'm sorry. Once I'm in the screen like this, the mute button disappears on me, except for myself. But I don't want to mute myself. But sometimes I need to mute hate to say it, I had to mute somebody, and I don't want to go searching for them, so I just hit the mute all. But it's not there right now, so just take it easy. I actually unplugged my phone a moment ago because it rang the last time. There are 5 phones in this place. I unplugged it and took the power out of it and everything. And then I looked around at the other phones. It disconnects them all. Ah, great. So total isolation. So I couldn't leave them blank. I had to put this one back in again. So I wish I could mute myself and still talk, but I can't do both at once. So hopefully we won't hear it. I'm getting phone calls from all over the world. You are too, aren't you? You getting calls that say unknown? Do you get phone calls that are from Irvine and you don't know anybody in Irvine?
Like spam calls?
All
Yeah.
the time.
All of the time.
Yeah. Okay.
Yeah, it's really annoying. And then you can block. I can block 30 of those calls. Big deal. They all have multiple numbers. And they switch their number to another call. Pretty soon my 30 are used up. Why do people want to waste their time doing that to me? They don't even know who I am. They don't know if it's fun or not. Okay. Starch is broken down to sugar. Well, one place the starch is broken down to sugar is in the mouth. Not very well, but in the mouth. If you were, for instance, to eat a cracker, a soda cracker, regular old saltine, that's mostly carbohydrate. Okay? And as you chew it, if on your saliva you have an enzyme called salivary amylase. Amylase breaks down starch, and the starch will become sugar. As far as an example is concerned, it's true, but it's not a great example because how many of us chew a soda cracker long enough for it to start tasting sweet? Nobody. Okay. Did your mother ever tell you something like chew your food 30 times before you swallow it? Anybody have that?
Yes, when we are little.
Yeah. If you chew just as an adult, if you chew your food 30 times and you're actually counting, okay, and thinking about it before you swallow it, you'd probably be disgusted. I would, because I'd be thinking of the food and what it must look like or whatever. But forget that. I'll just swallow it whole. Okay. But when you do eat a soda cracker, salivary amylase converts it to sugar. Well, if it gets a chance, it's got to have time. You're going to actually have to probably chew it 30 times. But like me, you probably swallow it first. And once that salivary amylase encoded piece of food hits the stomach, the acidity of the stomach stops the salivary amylase from working. So salivary amylase isn't a very effective chemical digester of starch in the mouth, not in the mouth. It does that job, and maybe at some point in our evolution it was important, but it's not terribly important now. Okay. We'll talk about the importance of the saliva though in just a second. Proteins are converted to amino acids. That does not happen in the mouth. That happens primarily in the stomach, and it'll also happen in the small intestine. Lipids, on the other hand, are just broken up into smaller and smaller globules. Large globs of lipid cannot be absorbed through the small intestine wall, They've got to be very, very small. And we can do that with the help of the gallbladder and the liver producing what are called biosalts. You don't see those words right here in front of you. They're coming. Okay. It'll all be written for you. But the biosalts help break down the fats or emulsify them. If you think of dishes in the sink, not in the dishwasher, but dishes in the sink, and they look nasty, it's time for you to go to bed or you're tired and you don't want to do them. I do the dishes in the morning usually. So you plug the sink, squeeze in some Dawn, and put the water in there. Cover everything. Look back at it. It's sudsy, white suds. It's beautiful. It's beautiful. Okay, so you go to bed. You get up in the morning, the suds are gone. And here's one big glob of fat floating in the middle of the sink, if it's able to. And what's happened is the fat has emulsified, but coalesced, in other words, come together. Okay. Now, if you have a glob of fat in the sink, and I don't want to conjure up disgusting images here, but take a fork, stick it in the fat, and swish it around. Well, you're breaking the fat up. You're emulsifying the fat. That's why I'm saying this. It's an example of emulsification. The small particles of fat that you break that glob up into are not nearly small enough, though, to be taken across the intestinal wall. The stomach does a little bit of this, not much. The small intestine does almost all of it. And the small intestine breaks the fat up to very, very small droplets or globules that can be absorbed. The fourth function of the digestive system, which people, they don't think about it, it's obvious. It's the storage of food. You could have a larger meal than if you had no stomach at all. You've heard of people who have had their stomach removed or reduced, and they can only eat small meals. And the stomach is meant to store larger meals so that you can go off and do things. Hunt, I doubt it, but somebody did. Think, build, play an instrument. Anything that you can think of that you can do is probably because the stomach has enabled you to do it. Okay? The Parthenon, the Eiffel Tower, none of these things would be in existence if we didn't have the stomach. Okay. Storage of food, very important. The digestive system is also important to absorb in absorbing the nutrients. Okay, so once they're converted to their simpler forms like sugars, amino acids, and emulsified fats, the digestive system has to do the absorption. Most of this activity is done in the small intestine, but some activity is done in the stomach. The stomach doesn't absorb a lot. It will absorb select things. It will absorb some medications. Okay? And some medications, come uncoated. They're meant to be taken up by the stomach. That way they bypass the liver. Other medications are coated or enteric. They're meant to get past the stomach and break down in the small intestine, be absorbed, and be taken to the liver, where the liver will act upon them. So, okay, so you have to, in making a medication, decide whether it's going to bypass or go to the liver. Okay. Alcohol is also absorbed across the membranes of the stomach. Okay. And then the waste products are compacted and there'll be reabsorption of water. Reabsorption indicates that there was a presentation of water to begin with. When you first see food, you see a table or a buffet or whatever, and you're hungry, okay? Your digestive system pumps at least a quart of water immediately into the small intestine and into the stomach, so that you'll be ready to have a substrate to do the absorption on and the breakdown of the foods. This water cannot be lost, and so as the foods being absorbed pass through the body, this water is reabsorbed. And by reabsorbing the water, the waste is compacted in the colon. The colon or large intestine is responsible for both of these. If we could make it just easy for a moment, there are two components of the digestive system. One is the GI tract. The GI tract is also long known as the gastrointestinal tract, or less frequently as the alimentary canal. That would be really in a biology class. Most people call it GI tract. Any part of the digestive system through which swallowed material, food, or by mistake, a marble or something, anything that these things can pass through is part of the GI tract, from in to out. That's the GI tract. So obviously the stomach is part of the GI tract. Large intestine, small intestine, esophagus, mouth, okay, anything at all. There are some organs, though, of the digestive system called accessory organs, and nothing is meant to pass through these. Okay? They instead deliver materials to the digestive system to help with the process. The accessory organs includes all organs that are not a part of the GI tract. The most important ones I've listed here for you: the pancreas, the liver, the gallbladder, and the salivary glands. Here's a cross-section of a head model, and it shows some of the important things of the digestive system. Some of the things that are pointed here or labeled here are not a part of the digestive system. Let's separate them. First, the hard palate. We know that is the palatine process of the maxilla. Okay, that's your hard palate. Put your tongue up against the roof of your mouth. There you go. Okay. Then you have behind the soft palate and hanging down a very small piece of tissue called the uvula. Now, you've all seen the uvula. You've seen it in cartoons. You've seen it in your own mouth if you took a flashlight to the bathroom mirror and looked in, the part that hangs down. The function of the uvula, some people downplay it. I guess I'm one of those, because the function of the uvula is really to go up and close off the nasal pharynx while you're eating or while you're swimming. Okay, but it doesn't seem to do a great job. This structure back here is not a part of the digestive system. It's the pharyngeal tonsil. We call this also adenoids. Adenoids. Pharyngeal tonsil. Below it, let's skip down to here. You see a rounded structure. And this is the palatine tonsil. There's one on each side of the body, so they're close together. These are the tonsils that give you the greatest amount of trouble. Has anybody here had their tonsils removed?
I have
How old were you?
31.
Oh, that hurt, I bet.
It was so painful.
Okay. Yeah, you don't want to have it done late in life, but if it's causing you that much problem that you know, I guess now it's all over with, right?
Yep.
Okay. Don't wait till you're 31, people. Okay. The palatine tonsils here, often the adenoids are removed at the same time. These are lymph nodes. Lymph nodes have a collection of white blood cells that help combat infection of the body. So they are important, but these aren't the only lymph nodes in the body. We're loaded up with them. Okay. Good, done these. This is the epiglottis. What's the epiglottis? I wish they'd have colored it better. It's right here. The function of the epiglottis is when you swallow, it is hinged down here in the front and it folds down and blocks off the start of the larynx. So food doesn't go down the so-called windpipe. Instead, the food goes down this tract in the back, which is the esophagus. We'll be talking about the epiglottis a lot. The epiglottis is cartilage. It's hyaline cartilage. It's this color here. Is that a baby blue?
Yeah.
Okay. You can barely see the baby blue here. There's more hyaline cartilage here and here. Okay, this top paragraph tells you a little bit of what we've already discussed, but it also mentions that a far greater function of the salivary amylase and the saliva is not to break down starch, it's to lubricate the food for movement through the pharynx and the esophagus. So in order to swallow things well or easily, we need the saliva. I know we've all had a time when your mouth is dry and you've unfortunately started to eat something that's also dry. Wish you could help it out. Okay, the pharynx we're going to describe. It's going to be broken into three parts. It's the portion of the GI tract from the exit of the nasal cavity to the larynx. The exit of the nasal cavity. Well, the entrance into your nasal cavity is your two nostrils. The nasal cavity is divided in half vertically. And when things go through the nasal cavity, like air when you breathe, okay, it exits through two portals, two holes at the back. They're called the internal nares. Your nostrils have another name. They're called the external nares. Here's the pharynx. Not here, nasal cavity. Starting here in blue, then it's switching color to whatever. And then it's becoming blue again, or lighter blue. These three colored portions here are the pharynx. It's divided into an upper portion called the nasal pharynx that sits on top of the soft palate and behind the uvula. When you open your mouth, if you ever do look into a mirror and look all the way to the back, you'll see sort of a rounded outline into the oropharynx. In the oropharynx, that's where your palatine tonsil is located. Below where you can see in the mirror, anything dropping out of sight, going down farther, is in the laryngopharynx. Okay, backing up to our definitions, the nasal pharynx extends from the roof of the pharynx and the end of the soft palate. Pharyngeal tonsils are located in the nasal pharynx. It's the adenoids. They are lymph nodes and they fight infection. The oropharynx extends from the nasopharynx to the level of the hyoid bone. Well, you can feel your own hyoid bone by putting your hand flat underneath your chin, flat and back, all the way back. Keep going back, sort of make your like a swallowing motion, going up and down. You can feel one piece that feels more like bone. If you don't know how to tell the bone from the cartilage, do it this way. Find the one that hurts. That's the hyoid bone. Okay. The laryngopharynx, you'll see that I spelled it, I think the proper way with an E. They left it out over here. I know it could be spelled both ways, but I prefer the E, doesn't matter. This part extends to the vocal folds. Vocal folds are here, but those will be protected, covered up by the epiglottis when we swallow. Here's another view. The nasal pharynx, here to here. Now, this is the nasal cavity. The entrance into the nasal pharynx would be here and here. Nasal pharynx at the back. Oropharynx here. And then the laryngopharynx down here. Salivary glands. These are accessory organs. They're not part of the GI tract. Nothing is supposed to go through them. Only salivary amylase and saliva are supposed to come out. Okay, we have sets of salivary glands. On either side, we have parotid salivary glands. I have a picture for you in a moment. Drained by the parotid duct. The salivary glands are exocrine glands. That's the first time you're going to hear that word here. Exocrine means they have ducts, and they deliver their secretion to a specific spot. They take it right over there. Okay. Sort of like a rain downspout. The water comes off the roof, gets collected in the trough, gets sent to the right or the left, and down a tortuous way until it hits the ground. So parotid glands produce salivary amylase. So do submandibular glands, which I'll show you in a moment. These are drained by a duct called Wharton's duct. The parotid duct is the same as Stenson duct, by the way. Sublingual glands vary in number, and they're located below the tongue. And those are drained by sublingual ducts. They can actually also absorb some things. For instance, nitroglycerin. I took a class, native plants class. I took it out on a hike. Every other week through the semester, we were going on a hike. And every week I made it more strenuous until we were climbing Mount San Jacinto. We started off in Holy Jim Canyon, the easiest hike. And my God, the class came up running up to me and saying, the guy that you were talking to, he's back there popping pills. He's popping pills. Oh my God. I go back there. We had to carry him out. That was awful. But he was putting them under his tongue, and the sublingual glands were taking up the nitroglycerin to help open the vessels in his heart. He was not supposed to come on a class like that. Here we go with the salivary glands. The parotid glands are right in front of your ears. And if you ever do need to wet your mouth, your dry mouth, you have to give a presentation or a talk or an interview while when no one's looking, rub circularly in front of your ears. And you'll be surprised how much fluid you'll get out of them. You know, they're holding back on you. Here's the parotid salivary gland on one side. Here's its exit, which is the parotid duct or Stenson's duct. The move is on to get rid of people's names again, and parotid duct is one of those that is catching on. So, in fact, I probably should tell you it has caught on. Underneath the jaw and just inside of it. So if you go back to the angle of the jaw and go to the other side, that's where you'd be pushing on the submandibular gland. It's sometimes referred to as the submaxillary gland. That's just in case you come across it in reading. Wharton's duct is right here. It's being called the submandibular duct. Either is fine. And here are the sublingual salivary glands. They have it listed as just one gland. It's really very closely associated, smaller glands. Okay, I'm not going to go over lingual frenulum today. Once food is swallowed, and it's sufficiently lubricated to be swallowed, okay, it will go down into the laryngopharynx. And the GI tract sends the swallowed food into the esophagus. The esophagus is about 10 inches long. It's a tube. It starts right at the end of the laryngopharynx. Food is expected to go down there, or anything you drink goes down there as well. And it leads from the thoracic cavity, because that's where this is taking place. That's where that epiglottis is too. The thoracic cavity is it goes from there to the stomach. It goes behind the heart, and it goes through the diaphragm that you have separating the thoracic and the abdominal cavities. The esophagus terminates at the cardiac sphincter. The top part of the esophagus, I'd like to have a picture. I'll go back. Here's the esophagus down in here. The upper portion of the esophagus has muscle that is skeletal muscle. And because of that, it's actually under voluntary control. We don't think about it very much. We let it do its own thing, but it's under voluntary control. If we were to eat something or drink something and it was too hot, or you realized, my God, that isn't my Coke, that's the can of pesticide I was going to spray or use. When you realize it's the wrong thing, you can spit it out. Okay, you can spit it out. And that's for protection. You can only do that because there is skeletal muscle in the top, about 1/4 of the 10 inches of the esophagus. After that, the muscle that lines the esophagus is all smooth muscle, and you have no voluntary control over it. Anything that gets to the smooth muscle that's going to make it all the way to the stomach, it's a one-way street there. If you get something, a piece of food, into the esophagus, it's going to go downward, and it's going to continue downward in a rather smooth motion, because it's going to be pushed from above down into the stomach. The smooth muscle encircles the tubular esophagus, and it crimps behind. Imagine that you swallowed something, a piece of candy whole, and it's round candy. Okay, crimp from behind, the candy moves downward. Okay, and then the next set of muscles right in front of the first set crimp behind and push it farther and farther and farther. It's like toothpaste, pushing the toothpaste from behind. As the toothpaste exits, you push further up, further towards the exit itself. Anything that is swallowed intentionally is called a bolus, B-O-L-U-S. So it doesn't matter if it's a piece of meat or it's a milkshake. It's a bolus. It goes down in little nodules. It doesn't go down as one big piece usually. The bolus enters into the stomach through what's called the cardiac sphincter. A sphincter muscle, this one is really important. A sphincter muscle is a circular muscle that opens and closes and it's meant to keep things moving in one direction. I'm not doing a great job with no, there it is. It keeps material moving in one direction. It allows things to go past it, but normally not to come back. We know that's not always the case. If you get sick, if something reaches your stomach and your stomach identifies it as a poison or something it doesn't want or can't have or too much or anything like that, yeah, we'll end up blowing groceries, and then you have the reverse. You'll have the reverse. You'll have vomiting. Okay. Let's look at the stomach first, and then we'll do the functions. Okay. Here's the esophagus reaching the stomach. It comes down, but there's a part of the stomach that's a little higher. This is called the fundus. The very most superior portion of the stomach is the fundus. This part here is the cardia, and it refers to all of this. We've got three important lines. This one, separating the fundus from the cardia. The cardia is big, not just that arrow. And here's the end of the cardia here. And then the third part, lowermost part of the stomach, is the pylorus. Fundus, cardia, pylorus. The cardia and the pylorus together obviously make up most of the digestive area, are called the body. The body of the stomach is the cardia and the pylorus. The entire inner wall of the stomach has rugae. These are large folds. These are not small intestinal folds that you'll be seeing later on. These are large folds because the stomach's going to act like essentially a washing machine. It's going to move the contents around. It's going to push, pull, squeeze, and push everything down towards the pylorus. And when it finally is small enough, it will leave the stomach through the pyloric sphincter. The cardiac sphincter isn't labeled, would be right here. Circular muscle, allowing entry in of a bolus, but hopefully stopping it from going back.
Hi, baby.
Yes.
Okay, give me the blanket because my legs are freezing. Mm.
I ate chicken again.
Okay. Okay, I guess I got it.
Charlie?
Yeah.
The thing that's not labeled, do we need to know that?
The cardiac sphincter?
Yeah.
Yes.
Okay. And is it that kind of, Go
Don't
ahead.
worry that it's not labeled here. We've got it elsewhere.
okay, thanks.
Here's the pyloric sphincter. The pyloric sphincter is the smallest, narrowest passageway that anything going through the GI tract has to maneuver. That's the smallest. It's got to get through there. If it can't get through there, it's not going on. The first part of the small intestine is shown here. It's the duodenum, but we'll deal with that when we come to the duodenum. Functions of the stomach. Well, we've already said storage of food, because that was one of the functions of the GI tract. Chemical digestion of proteins. Mechanical digestion of all food types. When I call this a washing machine, I really meant it. This thing really will churn the food and expose a lot of surface area. More surface area means more digestion. More surface area means smaller pieces. Smaller material means it gets through the pyloric sphincter. Some people eat things that are hard to digest, okay, for the stomach. Meat on its own is not terribly hard to digest. It just takes longer. They wonder why they feel full so long. Even the next day, they might still feel full. No, it's still in the stomach. It's still in the stomach. Okay. So chemical and mechanical digestion takes place in the stomach. There's some absorption through the, although the small intestine does most of it. I told you medications and alcohol can go across the stomach wall, and so can small amounts of certain foods. Vitamins can usually make it across the stomach wall. But the main function of the stomach is not absorption. The stomach also produces some hormones. Okay. We'll talk about that when we get to the endocrine system. Okay. But I want you to know that some hormones, especially for digestion, are produced in the wall of the stomach. Does that mean the stomach is an endocrine gland? Of course it does. If endocrine glands produce hormones, then the stomach is an endocrine gland. But I have to ask, what part of the body is not an endocrine gland? We have some that are obviously endocrine glands, like the pancreas and the pineal body and the skull and the pituitary gland. But almost anything communicates with the rest of the body. Some people have designated the entire GI tract as an endocrine gland. Well, I just said that. The whole body interacts with itself. Here's the three parts of the stomach. We know: fundus, cardia, pylorus. The rugae increase the surface area inside. And when we look at the stomach here, cut longitudinally, here's the fundus, unlabeled. Okay, here's the pylorus, here's the cardia. But we can also see that on the lateral side, this would be normally your left side. This is the greater curvature. The greater curvature. And on the other side is the lesser curvature on the medial side. That'll be important later. Now you notice I said the greater curvature is usually going to be on your left side. Usually. It's not with everybody. A surprisingly outstanding number of people have their internal organs in the abdomen reversed. Everything is reversed. Imagine being a doctor not knowing that a patient had that situation, going in and finding out, and then having to quickly make changes. greater curvature. Attached to the greater curvature is something called the greater omentum. We'll mention this again later. And it doesn't show here. But I'll just describe it. There's a membrane, very tough membrane, very thick, very fatty. And it comes down like an apron and covers all the rest of the small intestines. It comes back up and attaches at the other end of the greater curvature. This is called the greater omentum. It stores fat. It protects against trauma. It protects against cold. You'll see it soon. Okay. This is where I will stop this lecture and finish it on Tuesday. Now, Tuesday's lecture is not going to be on the Thursday test. You know that. Today's lecture is not going to be on Thursday's test. However, Tuesday's lecture is tougher. Okay, here's the material that's going to be going over. And it's not one to shy away from. Okay, let's get that out of there. 258, that's about right. Huh. I've lost your picture, but you can still hear me, right?
Yeah, we can hear you.
Okay. Well, we're going to take a break. Now, give me time to find your picture. Okay. Take a break if you would till oh, what do you normally like? 10 or 15 minutes? I've given you both.
15.
Okay. 3:15. Okay. See you back here then. There you are. Found you. Okay. Okay, anybody with anything to say either about what we just did or the test coming up next week? I'll set aside some of the time on Tuesday uh, for review, as I said, not just the myofibro, but anything at all. So if you have any questions as you're studying over the weekend, jot them down or something. Okay. Otherwise, we'll just end up signing off uh, when we get to that part. And I want you to get your best score. It's a hell of a lot of time, actually. Another week to study for that, and then another week after that we have the next practicum. Okay. Since I haven't heard one voice, somebody say something so I know I can hear.
We can hear you.
Okay, that's what I needed. Okay. Okay. What I'm going to do is first review with what I left you with the last time, and that was to try to get familiar with the first 12, I think it was, human muscles. But then I'm going to do the cat muscles, and then I'm going to do the so, some of the other muscles. Now, if you're looking at the screen with me, you remember the expanded version is optional. Okay, you can pretend it doesn't even exist. But the condensed version of the human muscles is the one you want, really. And it has the origins and insertions. And they are the same origins and insertions and actions, I should have said, as the cat muscles that follow. Now, a little bit farther on last week, I think I did muscles of the back. And did I do muscles of the chest? It doesn't matter. I'm going to be doing it again anyway. I did these, but I want to just point out muscles of the back, muscles of the chest, muscles of the forearm, abdominal muscles. All of these muscles, since they're human muscles, must be included here. Okay. And here is a different set of pictures. The more pictures that you can take a look at, I think the better. Okay. So I'll return to that set of 4 down here next week. Today I'm going to stay up here. I'm going to start with the human muscles and not the pictures that you were looking at. Okay, you were to do or to try to learn trapezius down to brachialis. In the brachialis, I left you on your own. So we'll start off fresh. And okay, this is a different labeling, but it's the same numbers. They use the same numbers throughout. Number one is the trapezius. There's three parts to the trapezius, but you only need to call it trapezius. But just to be a little bit more complete, this part of the trapezius, which is from here to here, this is the spinotrapezius because its origin is on the spine. Okay. This is the acromiotrapezius because its origin is on the scapula. And up here is the clavotrapezius, also known as clitotrapezius. And that's because its origin is on the clavicle. So we've got a rather large muscle here, okay? You only need to know it as clavicle, trapezius, okay? If you're asked which origin, any one of them could be given you, but the one that will be given you is the first one, the occipital bone. I'm going to go back to that first picture because it's got a little bit more than just number one. That's the trapezius. Here's the latissimus dorsi, sort of wrapping around you. If your midsection got hurt and needed to be wrapped. Okay, here's the latissimus dorsi. Muscle number 3 is not on this picture, so we'll wait for it and skip to muscle number 4 so that we can save some time and do some more. This is the rhomboideus or rhomboides. There's two parts, the rhomboides major and the rhomboides minor. Okay. Well, you only have to know it as the rhomboides, please. Okay. And it pulls the scapula together. Number 5 and 6 are on the other side, but we can go and do 8 and 9 and take advantage of the picture that's right in front of us. 8 is above the spine of the scapula. The vertebral border of the scapula is right here. And here's the lateral border. I could have called this the medial border as well. And I could have called this the axillary border. 8 is the supraspinatus. It occupies the supraspinatus fossa, which is how it gets its name. Many of the structures of the bones that you learned before lend their names to these muscles. Below, we have the infraspinatus. Now, we didn't see number 3. We can now see it under the arm. It comes out like a rake. The serratus anterior. We repeat the supra and infraspinatus and the rhomboides and trapezoid, just a different view. The serratus anterior helps to pull the arm in quickly and help to jab. In other words, then lunge forward with the help of other muscles. Number 5 is the pectoralis major, and then deeper underneath is the pectoralis minor. The origin of the pectoralis major is this broad, what we call tendon of insertion, with this broad area right here. A lot of it is on the sternum, moves across and is on the, has its insertion on the humerus. Pec minor, completely different look to it. The deltoid, in an arm that's been detached here, okay, has sort of a look of a flame, but the base of the flame is here, and the point is down here. I can, in my mind, make out the letter D for delta in this. But if you can't, then you have to figure out a different way to remember it. Although this one doesn't give too many people fits at all. The deltoid consists of three parts: the spinodeltoides, the acromiodeltoides, and the clavodeltoides, just exactly like the trapezius. But you're only responsible for calling it or picking it out of a group as deltoid. It will not be separated for you on the exam. But some of you, I know, want to get as much as you can. And so there's a little bit more available. We did the supra and infraspinatus triceps. This triceps, you got to figure this out. Now, this is a left arm. How do I know that? Well, put the left arm, put it out in front of you with your fist straight up and down. In other words, your thumb at the top, little finger at the bottom of your fist, and that's your left arm. If you reach over your upper arm to the outside, bottom part, you have three muscles, the triceps, meaning three heads. 1, 2, but the third head is hidden from you. It always will be. It's in between the other two. This muscle right here, number 12, I was looking back and forth. It will show better in the next picture. This is the brachialis. The brachialis. When you leave the triceps, coming medially, the first muscle you're going to hit, a cat or a human, is the brachialis. The next one, not labeled here, but it will be in the next slide, is the biceps brachii. Okay, so here's that brachialis. Here's the biceps brachii. And down here, what muscle might that be?
Triceps.
You you said triceps.
Yeah.
Okay, that's correct. That's good. That's the triceps, but you can't see the label. But the triceps is always followed by the brachialis. The brachialis and the biceps brachii are synergists. They work together to raise the forearm or to flex the forearm would be a better way of saying it. Okay, the one that is cat muscle says so. The others just say musculature. They're human. Okay, now this particular sheet here has the expanded version. You're not responsible for the expanded version. You are responsible for all the actions. They're not changing. But if you want, you can use the condensed version. The condensed human version is fine. It will work. Okay. There are a few differences, of course, between the cat and the human. You would probably expect there are tons of differences between the cat and human, but that's not the case. Okay. There's probably 5 major muscles where there's a difference. Okay, now let's look at this. And we are going to have questions on the cat. Now, of course, this always comes up small. Right here, I could enlarge it a bit. And it tells you what each thing is, 1A, B, and C. This is trapezius. We should have known that because we just clicked trapezius. This is the spinotrapezius, latching onto the spine. The acromiotrapezius is a thin layer. You could lift it off and it covers the scapula. And 1C, I'll show you better, is the clavotrapezius. That's this muscle up here. So now let's look at it larger. Okay. Spinotrapezius, acromiotrapezius, clavotrapezius. Here's where it starts, back here. We're making sort of a triangle. I'm not including that lower one. Getting this, come up, and go back. You do not have to give the name of the 3 parts. I used to, in fact, I think I'm the only anatomy teacher that insisted that my class learn all 3 parts. But I sort of backed off of that when we had to go online. Okay, so you can call any part of this, it's labeled the trapezius, and I can label any part of it. This upper part here, this part, this part. The latissimus dorsi on the cat is a broad, flat, lateral muscle. Latissimus dorsi. Well, it's sort of like the human. It attaches back here at the spine. It attaches to what we call the lumbodorsal fascia. That's this material right in here. It attaches and then it comes around and it goes and it inserts at the humerus. Taking advantage of number 4 since it's here, these are the rhomboides, and they protract or draw together the scapula here and here. These are rhomboides in here as well that weren't separated as these were. The serratus anterior again looks like that, the end of a garden rake. It does to me. Maybe my imagination's warped, but I see it. Or it looks like a hand coming out. Muscle that is subdivided so that it can latch on to different ribs is what it's doing. Okay. And that gives its many extra points of origin. This is the serratus anterior. Now up here, this 2 refers to the latissimus dorsi, which had to be flipped back out of the way because a moment ago it was down here covering this.
Charlie,
Yes,
are there going to be any pictures of cats on this?
yes, there are.
Okay.
Yeah, I'll be able to give you the exact number, after I take a look at it myself
Okay.
and put it together next Tuesday, and that's 2 days and plus a week. But yes, absolutely, there are going to be. I reviewed other schools over the weekend and what they do in their anatomy class, and some are skimpy. Okay, fine. You may think this is skimpy in a way because it's online. Online is just not where it really should be, I don't think. But they're almost all universally using the cat. If they don't use actual pictures because they didn't take them before they had to go online, they're using diagrams. I prefer the pictures.
Right.
Okay. Now, why are these schools using the cat? Because in order to get into certain nursing schools, I think I told you this last week, uh, dissection, or in our case, observation of dissection is required. And yes, we have the human cadaver, and we will have human cadaver photographs and muscles. And believe me, those will be the easiest ones you ever do. Okay. The pectoralis major and minor. Okay, on the ventral side of the cat, we would call it the anterior side if it were a human standing, of course. The pectoralis major is this one up here. Okay. Even in the human, we can't always expect major and minor to mean large and small. For instance, the rhomboides major and the rhomboides minor switch sizes on us. Okay, the minor is the larger one. Okay. Here is the pectoralis major from here to here. It's roughly triangular on either side, but it does attach to the humerus and draws the arms across the body. Below it, okay, attached to the ribs, just like it was in the human, is the pectoralis minor. We'll come back to number 11, but for right now, I'll just tell you it's the biceps brachii. We'll come back in just a second. Here's the deltoid on the cat. Now, the deltoid on the human was the shoulder. Okay, the lateral portion of the shoulder anyway, and it is here too. It's this muscle and this muscle and this muscle down here, all interconnected. Okay, so it's our shoulder. Here's our triceps. If that's the triceps, the next one's the brachialis. And I'll show it to you in a moment as number 12, but it is the brachialis. Okay. This is the spinodeltoid. This right on the top of the shoulder. This is the acromiodeltoid. And then this one, way down here, is the clavodeltoid, just like in the trapezius. Spino, acromio, and the clavo. The clavodeltoid, watch me, moving up, runs right into the clavotrapezius. This is an instance where a muscle attaches to another muscle. Okay. We'll see that again many times before you get possibly tested on that one. Where else do we have muscles attaching to muscles instead of muscles attaching to tendons to bones? The face, around your eyes, the orbicularis oculi. Okay, it winks, but it doesn't do it by attaching to bone. Same thing with your mouth, the orbicularis oris. Okay, it attaches in a circular method to itself. Okay, so the answer to any of these pins is deltoid. Now you can probably get the impression, and you'd be right. He's well, we do go over a lot of the functions and stuff in class, but we always go over the name of the muscle. So the first thing you got to do is get the name down, I think, and then the origin, insertion, and action. Some people learn them at the same time. Okay, you learn the name of the muscle, but that's first, and then do the origin, insertion, action. So number one, and the stuff. Number two, and the stuff. Number three, and the stuff. Others, they learn all the muscles first, and then go back and start learning the actions. That's okay. Either way, you still have to know the muscles first. And you also realize that what we do here is sort of the same as in a face-to-face class. We show you the material, we show you the muscles, but you gotta go home and do the homework. You gotta learn the origins, insertions, and actions your way, the way that you'll remember it. Okay, I was here's a scapula, big in a cat. It's right here underneath all this. And number 8 is the supraspinatus muscle. And number 9 is the infraspinatus muscle. And this area here, where nobody could pull away the skin, is because it's attached to the spine of the scapula. And so that's the separation point. Here's the triceps. Immediately in front of the triceps, still unlabeled, but it will be in a second, is the brachialis. This is the clavodeltoid. Up here, the clavotrapezius. This material, what's left of it after it's shredding, is the acromiotrapezius. And here's the spinotrapezius. If I didn't say it already, spinodeltoid is right there. Acromiodeltoid is right there. Just because it's only got three things labeled, once you start getting used to it, you can get a lot more out of the picture. I already showed you the triceps, okay. We don't need that one again, I hope. I said I'd come back to this one. Here's the biceps brachii down here. This is a little different. You and I don't have this muscle. That's okay. We're not going to learn it, obviously. We don't want to learn a muscle that a cat has and that we don't. So we've only labeled and picked muscles that are also common to humans. Here's the biceps. Okay, and now here's number 12, the brachialis. Triceps over here at 10. When it ends, we have brachialis immediately. And what's the next one? This is clavodeltoid and clavotrapezius. Where the heck is the biceps brachii? Well, we have to go into this opening here and fish it out. Okay, it doesn't show on this side, but the brachialis and the biceps brachii definitely are synergists. Okay. I'm going to start the next group of muscles on the forearm. I'm going to start with the cat because I believe it's much clearer on the cat. On the models that we have, they're great models. We have to pay $1,600 for each arm. Crazy amount. But they can be confusing. So we're going to get rid of the confusion by looking at it on the cat first. Okay. Flexor carpi ulnaris. This is going to flex the wrist and adduct the hand. Put your hands in anatomical position. That is, put the palm forward. The thumbs are going to be lateral. And if you're going to adduct the hand, you're going to take your little finger on each hand and bring it in. Turn your hand in. That's to adduct. Okay. Please try these out first. Oh, you don't have to latch on to the origin insertion, but think of the action, what it does. Try it yourself on you. Okay. Now, for a moment, this looks maybe impossible, but it's not at all. This is the flexor side of the cat's arm. It's the underside, you might call it. Okay, it's lying on its back with the arm spread out. The paw up here. Number 13. It's this muscle here. It's the flexor carpi ulnaris. Flexor because it's on the flexor side. It is going to cause these digits and the wrist to flex, to come up, okay, to come up. So flexor, let's follow where it goes. I know you can't see behind the thing, but it goes right about here. Flexor carpi, because it goes to the carpals. Ulnaris, because it's on the side of the little finger. The thumb is going to be here, okay? Just hold your hand up like you're saying hi or whatever to get in this position. This is on the ulnar side. Now the trick is get one good starting point on each side of the arm. With one starting point, you can go in either direction and name the next one and name the next one. This is the not a great starting point, actually, number 13. It's kind of a tough one. I might pick another one. I like 14. There won't be a number 14 in the test. It won't have a pin in it. But this is a nice, flat, soulfish looking muscle. This is the palmaris longus. It goes out and it attaches to all of the digits and flexes all of the fingers, if you would, if I can call those digits fingers on a cat. Okay. So when a cat's pulling its claws back, it's using the palmaris longus. Now, if I use the palmaris longus at the start, and I can figure out which side is the thumb, the next one over has got to be the flexor carpi radialis. I'm sorry, flexor carpi ulnaris. Got to go slower if I were taking a test. Okay, here's the palmaris longus. Find your own palmaris longus by taking on one hand, your little finger and thumb and touching them together. And now flex your wrist slightly, and there should be a cord-like tendon that pops up. You've seen it a million times on yourself and everybody else. You see that tendon on the underside. Okay. That's the tendon of the palmaris longus for you. How many of you have more than one of these tendons?
Looks like I have two.
You have two? Okay.
Mhm.
Anybody else? I had a guy once that had four. Typical is one, but not uncommon at all is two. We should have had more than just one person in here with two. Okay. Does it make you any stronger? No, it doesn't. Doesn't at all. Because they still attach to the same muscle, going the same direction, not going to help make you any stronger. But if you were somehow going to bust one, you'd have a spare. Here's the palmaris longus. Now let's go the other way. The next one over. This muscle is the flexor carpi going to the other side of the wrist, radialis. Flexor carpi radialis. I don't know if you can see it in this picture, but this muscle is split right here. And down here, this muscle has a split. They're both carpi muscles going to the wrist. There are going to be four carpi muscles, and I'll repeat this later. All four carpi muscles have two heads. All four carpi muscles will split. All four carpi muscles will have two parts. Can't see it in this picture, I know that. Okay, so don't think I'm expecting you to get it yet. It's just so that you're not confused if you do happen to see it. Okay, this is the nice thing about the palmaris longus as the starting point. On each side is the flexor carpi. Flexor carpi ulnaris here. Flexor carpi radialis here. If you were to contract both the flexor carpes that we just looked at the same time, they would flex the wrist. That makes sense, wouldn't they? Thumb side, ulnar side, both sides coming up. So these two muscles can be synergists. However, what if I only flex this one? And it's going to bring the thumb in. That's going to abduct. I know you're thinking adduct, but it's going to abduct. And if this one is only one that's working, it will adduct. And in that case, they are antagonistic. This is a set of muscles that can work both ways. They can work together, or they can decide not to work together. Think of it sort of maybe like two guys with a big log, and they pick it up, one from each end, and they take it someplace. They're being synergistic. They're helping each other out. But on the other hand, if they pick it up, one at each end, and only one of them moves in any direction, the other one is working against it just by standing still. It's antagonistic. Okay, this one is the palmaris longus again. Palmaris longus. Where's the thumb side? Here's its head. Thumb is here. We can't see it. Too bad. It would have been nice to have it in the picture, but the thumb side is over here. So here's the palmaris longus. And this next muscle is the flexor carpi radialis. We just saw that one. Number 15. Here you can see it's broken into two parts. When I say broken, that's really a bad choice of words. That's the way it's supposed to be. And then the next muscle we have, number 16, is the pronator teres. It's a short muscle, only about half as long. It ends about here. It curves across the middle of the elbow to the radial side, going towards the thumb side. And what it does, it is a pronator teres. It pronates the arm, turns it down, turns it down. So if you have your palms up for a second, now turn your palms down, you just used your pronators. Now we're on the flexor extensor side. So we're on the other side now. The cat is looking downward. Okay. Here's our triceps. Here's our spinal deltoid again. Okay. Now, We've lifted up one muscle. It's a thin muscle. In live dissection, it often breaks, and then people don't know what the hell is going on. But this is a perfect example of the brachioradialis, number 17. But notice that the pin, number 17, first enters this muscle right where the pointer is right now. Whatever the pin goes through first, that is what is being asked, not what the pin is anchored in. That has nothing to do with anything. This is the radiobrachialis, also can be called the brachioradialis. If you say it fast enough, it sounds like the same word, radiobrachialis, brachioradialis. But either way you say it, this is the muscles you have. Not humans, this can be much bigger. And I said can be much bigger, not terribly large in most of us, but in bodybuilders, oh yeah, immense. Then come down to the next muscle. And this one is a nice large muscle, can actually be seen from both sides. This is number 18 on our sheet here. It's the extensor carpi, because it's running to the carpals, radialis, because it's running to the thumb. Extensor carpi radialis. And this is one of the muscles then that will extend or hyperextend the wrist. The next muscle coming under that one is here. It goes out right to all the digits, right in the middle. This is the extensor digitorum communis. Sometimes it's being called the extensor communis. Some other times, extensor digitorum. Well, it won't fool you. Never fools anybody. This one extends all of the digits. There's another one right here. I'm going to show you in another slide, but that one only extends one digit, the little finger. And that's the extensor digitorum minimi. This muscle down here is the extensor carpi ulnaris. Let's see it on a different slide. Okay, here's the minimi. This one up here is extensor digitorum communis. It turns somewhat on you. We can see the brachioradialis here. Here's the extensor carpi radialis, extensor digitorum, extensor digitorum minimi. Now the last one is the extensor carpi ulnaris. Okay, that brings us to the masseter, and we're going to do them on the human model, but that's as far as we'll go on either of them. Okay, so Same muscles. Starting with flexor carpi ulnaris. I see the problem right away is if we'd have started here, we don't even know where the thumb is or anything. There's quite a few things though that give it away. This little half muscle here, that's the pronator teres. You know, it doesn't have a sign or anything on it, but from the cat, we might know what this one is. Obviously, this is going to be the wrist. We are going to be naming the parts of the wrist later on. I like this one. Look where it comes, right down the middle. There's that tendon that I just had you look for. This is the palmaris longus. If this is the palmaris longus, on either side are flexor carpi muscles. This is the flexor carpi ulnaris, flexor carpi, and it's on the little finger side. This is the flexor carpi radialis. We are not including the superficialis muscles, which are this one and this one. They're not part of your study packet. Okay. We'll next label the pronator teres 16 and probably rotate number 13 back out of sight. Yeah, we did rotate 13 and 14 out of sight. Here's the pronator teres. Now, right here is the anterior side of your elbow. We're coming across to the other side. This is the flexor side. This is the extensor side. Number 17, when you're looking at the pictures, is the same on the human or the cat. It's the brachioradialis. Brachioradialis. We'll see it again. Well, we can't really see it on this one. It's way up here. It's that little piece of tape. That was the brachioradialis. Now you're looking at an arm, like you're going to punch the wall. You're going to punch the wall. Okay, but you're going to look at your arm from the outside. Okay, not from the inner side. So your thumb is up here. These muscles are going to the thumb, and we will learn those. Not today. And now here are two muscles. The top by your elbow. The first one, if you were hitting your self there, is this one, the brachioradialis. Then there are what look like two muscles, but it's only one with two heads. Number 18 is the extensor carpi radialis, just as it was in the cat. Extensor carpi radialis. It's so hard when you have these models in your hand to convince yourself that these two are not separate muscles. They're the same. Even though at this end, this one joins the brachioradialis and it looks like a perfect seam. They are not together. 19 coming across, flares out and goes to all digits. This is the extensor digitorum communis. It can also be called, as I said, extensor digitorum or extensor communis. This one goes and lifts all of your fingers, extends all of your fingers. Number 20, wish the person who taped this had cut it a little smaller. It's this muscle here. And that's only going to the little finger. That's the extensor digitorum minimi. Minimi. And just like in the cat, the last muscle is the extensor carpi, going to the wrist, carpi ulnaris. For those of you who get tired of studying for the lecture test, I would tell you one thing. Go back and study for the lecture test. Okay, but if you really can't be dissuaded, you want to go ahead on any of the muscles, okay? Even a quick look, it can help. When it says not required by anything, literally nothing will be asked there. The extensor pollicis is that muscle that goes out to the thumb. So it extends digit 1. That's the only two things you have to know, the name and the action. Okay. So where it says not required, there's nothing for you to do there. Okay, any questions? How are you guys at public speaking?
I'm okay.
Pretty all right.
Not
Really? Because I don't hear anything. Most people are not okay with public speaking, you know.
How many questions are on the lecture test?
100.
Okay.
Yep. That's the only things that don't have 100 are quizzes. You know, they can have any number. They're there for, just to help you. I will post a quiz this weekend that will help you to with the muscles. No, muscles. We don't want muscles, do we? Yeah.
I have a question.
I'll
For-
post a quiz irregardless. Okay, go ahead. That's the question.
For the lecture exam, will the quiz, is it formatted just like the quizzes?
Oh yeah.
Okay, so the questions are similar, just like the quizzes every week. So it would be good to go over each one right before.
Yeah. And
Okay.
not just right before. I do it earlier than that.
we've had our last quiz, right, for this lecture? Quiz 5?
If you did the one I put up on Tuesday,
Yeah, okay.
I think after those went up, you should have an idea what the test is going to look like.
Okay.
Okay, and you can't learn it just from quizzes, though. You got to read it, study it. Okay.
I have a question actually.
Yeah.
Are you
Yes.
gonna add the extra credit from like when we did
like from the last test that we took, and we got like a higher score, because my score is still like the same as the test, but the extra credit hasn't been added in.
Okay, Bella,
Yes.
I just want to be sure that you're the one asking me.
Yeah.
Send me an email
Okay.
and tell me to check that.
Okay.
Okay, there will not be any extra credit on the lecture test because I saved the Zoom credit, I call it, okay, for the practical. You'll get it. And I do have once you finish the quiz next week, test next week, I will be having a small bonus quiz, okay, in addition to the Zoom points. As I told you, I would, to make sure that you get all the opportunities that the other classes have, and it will be on the buses. So, okay, yeah, but I'll take a look at it, see what you got on your quiz, okay, and be sure that you get everything you deserve.
Was our grade supposed to stay the same on Canvas, or it was?
You didn't get flustered when I talk about Canvas grades. Never, ever, ever use Canvas grades.
So whatever came in the email you sent out is our grade, right?
Yes, unless you think it's wrong, as Bella is wondering, okay, and then you ask me, and then if it's wrong, I'm going to change it. Okay,
Oh, so the extra credit isn't in Canvas.
of course not.
It's
Oh,
just in that email when he sent with like the numbers. Yeah.
oh, okay. Okay, that makes more sense. Okay, then I'm good.
You're good. You're good too.
Yes.
Yeah, Canvas. Please don't even look at the word grades in Canvas. They don't know to put in extra credit if there is any. They don't know if I change an answer. If I change an answer, for instance, you find one that was wrong, and some you did the wrong, the correct answer wasn't chosen. Okay, and I had to give everybody a point. I just gave you a point. I did it. If I were to go back to Canvas and say, oh, I want to change this one, it will make me ask me if I'm going to inform you now or ever, and it's just crazy, you know. I've been doing grades for 40 years, and I know there's mistakes made, and when they are, I'll fix it. But Canvas won't. Sorry, Canvas has not been around 40 years. Okay, so you said most of you are good with your score that I sent you. That's why you gotta be sure to read your email. Okay. I cut back on them this weekend, and so did you. So did you. Okay, so if you want to exit, we'll see you Tuesday. If you want to stay and ask a question, well, I'll be here.
Thank you.
Bye bye.
Thank you. Thank you. Thank you.
Bye.
Bye.
Thank you.
Okay.
Charlie.
Yeah.
Do you know anything about dog muscles?
Not really. I bet you they're not very much different.
My dog tore her ACL, so I wanted to know if you knew anything about it.
No, I don't.
You don't know?
Not an orthopedic. Sorry.
It was stressful. All right. Thank you. Just wanted to know. Bye.
Bye.